Airflow failure, postmortems, engineer-trusted language. Welcome. Today we're turning stressful outages into progress with practical, engineer-friendly postmortems. A good postmortem doesn't hunt for a culprit. It turns failure into learning, not blame. That mindset invites honest data and faster improvement. You also create a trusted record engineers can revisit what broke, why it broke, and how we fixed it. Over time, this becomes your team's memory. Finally, solid postmortems directly improve the reliability of Airflow pipelines, fewer surprise failures, clearer alerts, and safer changes. Think of this as preventative maintenance for your data platform and your team culture. Start by anchoring the event. Name the exact DAG, task, and run ID so anyone can reproduce the context. For example, DAG, sales_ETL. Task, load_redshift. Run ID, scheduled_the 1st of March 2025, T 2 hours 0 minutes and 0 seconds Z. Then timestamp the incident timeline. When it started, when alerts fired, when mitigations happened, and when it fully recovered. Time boxes reveal latency and detection gaps. Finally, state the business/user impact plainly. Which reports were delayed, which downstream jobs missed SLAs, and what decisions or revenue were at risk. Clear scope sets expectations and prevents vague, unhelpful summaries. Describe only symptoms and signals you observed. Error messages, failed tasks, backfills piling up, or dashboards showing stale data. Treat these as clues. Use logs, metrics, and alerts as your evidence. Include error excerpts, task duration spikes, retry counts, and alert timestamps. Link signals to moments in the timeline. Avoid guesses and personal attributions like Alex broke it. Replace that with neutral observations. Deployment X at 1:58, coordinated universal time changed connection settings. Task failures began at 2:01, coordinated universal time. Facts make the narrative reproducible, and keep the discussion focused on systems, not people. Start by identifying the failing invariant, the rule that should always hold but didn't. Example, target table accepts only non-null order _ID. Then trace code, config, and data changes near the failure window. Recent PRs, Airflow variables, connection settings, schema migrations, feature flags, or external API shifts. Use the 5 whys to move from symptom to a stable cause. Task failed, right pointing arrow Y. Type mismatch, right pointing arrow Y. Schema changed, without contract, right pointing arrow Y. Migration, lacked validation, right pointing arrow Y. Missing test and review gate. Stop when further whys. Don't change the remediation you would implement. List the conditions that made the failure more likely or harder to detect. Consider environment, dependencies, and quotas. Spotty network, throttled APIs, or rate limits. Check alerting, run retries, and SLAs. Were alerts noisy or missing? Were retries misconfigured, masking failures, or exhausting quickly? Validate that SLAs matched business expectations. Review docs, runbooks, and code review gaps. Unclear on-call steps, outdated playbooks, or reviews skipping data contract checks. Contributing factors don't shift blame. They reveal leverage points for future resilience. Separate the immediate fix from the long-term fix. Immediate might be a hot fix, backfill, or config rollback. Long-term addresses underlying risk, schema governance, validation, or pipeline redesign. Assign an owner, deadline, and success metric so work doesn't drift. Example: owner, data-ing, due Friday. Success: no failures in 14 days, and backfill completes within SLA. Finally, prevent recurrence with tests/guards, contract tests, canary runs, idempotent tasks, and alerts that fire on early signals, not just final failures. Make every action specific, testable, and time-bound. Use precise terms so readers map your words to Airflow concepts. Say task, DAG, operator, run, connection, variable, XCOM, retry, SLA. Quantify impact: duration of outage, rows affected, batches delayed, dollars at risk, or dashboard's stale hours. Numbers turn concern into prioritization. Keep wording neutral and reproducible. At 2:14 Coordinated Universal Time, alert X fired. Logs show Postgres operator error, invalid input syntax. Avoid adjectives like catastrophic unless you provide measurable impact. Precision builds credibility and makes your postmortem a reliable engineering artifact. DAG, sales_ETL. Task, load_redshift. Failure followed a schema change. Primary alert fired at 2:14 Coordinated Universal Time. Symptoms, retries exhausted. Error showed invalid typecasting for column total_amount. Impact, daily revenue dashboard delayed 3 hours, approximately 12 rows pending. Root cause, mismatched column type after schema change. No contract test to catch it pre-deploy. Contributing factors, retries hid the issue for 20 minutes. Alert lacked column-level context. Fix, add a schema migration step in contract test in CI. Enforce PR checklist item for data types. Owner, data-ing. Success metric, 0 type mismatch failures for 30 days. Backlog fully backfilled.